Imagine you are standing outside on a clear night. The sky is calm. The stars are where they have always been. You take a breath and feel safe, the way humans always do when they look up and see nothing changing. But tonight something is different. There is a new point of light near Jupiter. It wasn't there last week. It doesn't twinkle. It doesn't move the way a plane does. It just sits there, steady, cold, impossibly bright for its size. And within 72 hours, every government on Earth will go silent. Because what is coming toward your solar system is not a comet. It's not an asteroid. It is a dead star, a neutron star, and it is already too late. Let's make something clear before we go any further. A neutron star is not a star the way you imagine one. It doesn't burn. It doesn't glow with warmth. It is the corpse of a sun that died so violently that its core crushed itself beyond anything your mind can picture. Take our sun. Now squeeze everything it is, every atom, every particle, every whisper of light it has ever produced, and compress it into a ball the size of a small city, about 20 kilometers across. That's it. That's a neutron star. A single teaspoon of its material would weigh somewhere around 6 billion tons. That is more than every building, every ship, every vehicle ever built by human civilization, combined in one spoonful. The surface gravity is 200 billion times stronger than Earth's. If you dropped a marshmallow onto a neutron star from just 1 meter above its surface, it would hit with the force of a nuclear bomb. This is not a metaphor. That is the physics. And now one of these objects is drifting toward your neighborhood. But here's the problem. You wouldn't see it coming. Not really. Neutron stars are small, absurdly small for the destruction they carry. A 20-kilometer object against the blackness of interstellar space is invisible to almost every telescope ever built. By the time we detected the gravitational disturbances it was causing, it would already be inside the outer edges of the solar system. And once it crosses that line, there is no defense. There is no plan. There is nothing in any textbook or any government facility on Earth designed for this. We would simply watch. The first thing to die would be the orbits. Not Earth's orbit. Not yet. The outer planets would go first. Neptune, Uranus, Saturn. These gas giants we think of as eternal fixtures of the sky would feel the neutron star's gravity like a hook dragging through still water. Their orbits would stretch, distort, some pulled closer to the intruder, others flung outward into interstellar space like stones from a broken necklace. Saturn's rings, those delicate veils of ice and dust that took billions of years to form, would unravel in weeks, not shattered, unraveled. Peeled apart by tidal forces so precise, they would separate particles by density, turning a masterpiece into a stream of debris spiraling toward a dead sun. And this is where things change, because the neutron star doesn't need to touch anything to destroy it. Tidal forces are what happen when gravity pulls harder on one side of an object than the other. On Earth, the moon's tidal forces give us ocean tides, gentle, predictable, romantic even. A neutron star's tidal forces would crack a planet in half. As it moved closer toward the inner solar system, Jupiter would be the first giant to truly feel it. The largest planet in our solar system, a world so massive it could swallow 1,300 Earths, would begin to visibly deform. Its atmosphere would stretch toward the neutron star, pulled into a teardrop shape, then a stream, then a spiraling river of gas feeding into an accretion disk around the dead star. Jupiter, the guardian of the inner planets, the gravitational shield that has deflected countless asteroids away from Earth for billions of years, would be dismantled like wet paper. But that's not even the worst part. Because while you are watching Jupiter dissolve through whatever telescope is still functioning, something is already happening on Earth that no one expected. The ground beneath your feet begins to shake, not like an earthquake. Earthquakes have a rhythm, a pulse, a beginning and an end. This would be continuous, a low, rising vibration that starts in the deep ocean trenches and spreads across every tectonic plate on the planet simultaneously. The neutron star is still hundreds of millions of kilometers away, but its gravitational influence is already reaching Earth's core. The molten iron inside our planet would start to shift, to slosh, pulled unevenly by a force it was never designed to resist. Volcanic chains that have been dormant for 10,000 years would erupt in sequence, not one. All of them, the Yellowstone caldera, the Siberian traps, The Pacific Ring of Fire all at once, like a string of firecrackers lit by the hand of something that doesn't care about your civilization. But it gets worse, because the ground shaking and the volcanoes are just side effects, background noise. The real horror is what is happening to the ocean. Tidal forces from the neutron star would create waves that make every tsunami in recorded history look like ripples in a bathtub. We are talking about walls of water kilometers high, moving at the speed of sound, circling the planet as Earth rotates beneath the gravitational pull. Coastal cities wouldn't flood, they would cease to exist. The water wouldn't recede, it would be pulled permanently toward the side of the Earth facing the intruder, leaving half the planet drowning and the other half a cracked, dry wasteland within hours. And here is something no one talks about: the atmosphere. Earth's atmosphere is held in place by gravity, and our gravity is gentle. It is a thin, fragile blanket. A neutron star passing through the inner solar system would begin stripping it away. Not all at once, layer by layer. The upper atmosphere would go first, peeled off like skin from a burn, molecule by molecule, carried toward the neutron star on streams of charged particles. The ozone layer would vanish. Ultraviolet radiation from the sun, normally filtered to survivable levels, would pour onto the surface unimpeded. Every living thing exposed to open sky would begin to burn, not metaphorically. Your skin, your eyes, the leaves on every tree, and this is still happening before the neutron star is anywhere close to Earth's actual orbit. But here's what truly keeps astrophysicists awake: the magnetic field. Some neutron stars are magnetars, objects with magnetic fields 1,000,000,000 times stronger than Earth's. Even a standard neutron star carries a magnetic field billions of times more powerful than anything on our planet. As it approached, this magnetic field would interact with Earth's own magnetosphere and simply erase it. Our magnetic field is the only thing protecting us from solar wind, from cosmic radiation, from the constant stream of charged particles the sun throws at us every second. Without it, the radiation environment on Earth's surface would become lethal within days. Not uncomfortable, not elevated risk, lethal. Every cell in your body would be hit by ionizing radiation at doses that would make Chernobyl look like a dental X-ray. And we haven't even discussed what happens if this thing gets close. Really close. If a neutron star passed within the orbit of Mars, the scenario stops being about destruction and starts being about physics we have never witnessed at this scale. Earth would not simply be pulled apart, it would be spaghettified. The same process that happens to matter falling into a black hole. The side of the planet closest to the neutron star would be pulled so much harder than the far side that the entire planet would stretch into a long, thin strand of molten rock and iron, spiraling into an accretion disk of superheated debris. In 2017, the LIGO Observatory detected gravitational waves from 2 neutron stars colliding 730 million light-years away. That single event released more energy than our sun will produce in its entire 10 billion-year lifetime. Now imagine that kind of gravitational violence not happening in a distant galaxy, but inside the orbit of your own planet. But even if the neutron star passed at a relatively safe distance, say beyond the orbit of Jupiter, the damage would still be permanent and total. Earth's orbit would be altered. Maybe pushed closer to the sun, where the oceans boil, maybe flung outward, past Mars, past the asteroid belt, into the cold dark, where temperatures drop to negative 200 degrees, and the atmosphere freezes solid and falls to the ground like snow. Either way, Earth as a habitable planet ends not in a dramatic explosion, in a quiet rearrangement of numbers, a few degrees of orbital change, a slight shift in distance from the sun. That's all it takes to turn a living world into a dead rock. The Voyager probes, launched in 1977, are still out there drifting through interstellar space. They carry golden records with greetings in 55 languages, music, images of Earth, messages from a species that believed it had time, that believed the sky was permanent, that looked up at the stars and saw beauty instead of threat. But a neutron star doesn't read golden records. It doesn't negotiate. It is a piece of physics left over from a catastrophe that happened billions of years before humans existed. Wandering through a galaxy that has no interest in preserving anything, and here is the part that should unsettle you most. There are an estimated 1 billion neutron stars in our galaxy alone. Most of them are invisible. Most of them are wandering. We have mapped only a fraction. We would not see one coming until the damage had already begun. There is no alarm system, no early warning, no shield. The universe did